The night has settled like velvet across the sky, and the room around you has grown still. Your body is softening into the mattress, breath finding its own rhythm. There's no urgency here, no noise, only the hush of rest approaching. Let your eyes grow heavier with each passing moment, like shutters closing gently on a world preparing to dream. This is your time to drift, and tonight the stars will keep you company. Out there, scattered like distant embers, are lights that have crossed a vast and silent darkness just to reach you. Tonight, we'll journey into that soft radiance, the strange and beautiful truth of starlight. We won't chase answers. We'll let them arrive slowly, like dawn slipping through the blinds. Each glimmer above holds a secret, and together we'll trace the stories folded within the light that touches our world so tenderly. Before we begin, take a moment to notice the stillness around you. You're not alone in this quiet. All around the globe, others are sinking into the same night, the same stars above. I'd love to know where you're watching from and what time it is for you right now. Drop your location and local time in the comments. Together we'll form a little constellation of our own, scattered minds resting under a shared sky. Some nights, when the air is especially clear and your eyes haven't yet grown sleepy, a single point of light above can feel like it's watching you back, not blinking, not wavering, just being, and you might wonder, how far away is that light? How long has it been traveling? Is it still coming from a star that exists right now? Or is it just a whisper of something already gone? Starlight is a kind of time travel, but not the sort with whirring machines or paradoxes. It's subtler than that, more faithful. When you see a star, you're seeing it not as it is, but as it was, years ago, maybe centuries. That twinkle in the sky might have been born before you were, before cities, before stories, before names. It's like a message in a bottle tossed across a cosmic ocean, arriving on your shore without ever having known your name. But what exactly is this light that can cross such impossible distances without tiring? It isn't a beam like from a flashlight, flickering out over time. Starlight doesn't weaken the way we expect things to. It doesn't weigh anything. It doesn't get old. The light from a star is made of photons, tiny massless particles that move at the fastest speed allowed in this universe. They leave the star, travel through the vacuum of space, and if no dust or planet or black hole interrupts them, they eventually touch your eyes, or your pillow, or your window pane. A photon doesn't experience time the way we do. It's born, it travels, it arrives. But for the photon, that might as well be the same instant. No ticking clock inside it. It doesn't age. It just exists in motion. So when you gaze up at the night sky, you're not just looking far away. You're also looking backward, through time. The longer the light has traveled, the older the image becomes. Some of the stars you see tonight might already be gone, their light still en route to Earth long after the fire has faded, and yet the light feels fresh, new, even comforting, like something alive. How can something that's traveled millions of years across silence still feel so immediate, so present? Imagine if every time someone smiled at you, you were actually seeing a smile from years ago. Or if the warmth on your skin came not from the sun above you, but from a sun that once was. That's what starlight is, not the presence of something, but its echo. It's hard to grasp how far this light has come, how empty the space is that it's moved through. The nearest star to our sun is over 4 light years away, and that's close by cosmic standards. A light year is the distance light travels in 1 year, nearly 10 trillion kilometers, which means the light you see from that nearby star tonight left on its journey before the pandemic began, before your last birthday, before 1,000 little things changed in your life. Some of the light above has been traveling for hundreds, thousands, even billions of years, from galaxies too far to name, from stars that were born when the Earth was still molten. You're not just falling asleep under a sky. You're surrounded by stories, by fragments of ancient moments that managed to survive an unimaginable voyage through space just to arrive at this very second above your bed, beside your breath. And somehow, your body catches them. Your eyes, even closed, are still touched by that light. It slips in through your eyelids, diffused by the warmth of your skin, signaling that the universe is still there, still spinning, still glowing. Starlight is one of the few things that makes the vastness of the universe feel less cold, less indifferent. It's light with no master, light that belongs to no one and touches everyone. You don't have to own a telescope to receive it. You don't have to be a scientist to notice it. You just have to look up or close your eyes and imagine. Maybe starlight is the most democratic thing there is. It shines on rooftops and oceans, deserts and sidewalks, prison cells and playgrounds. It arrives without asking, without judging, without needing a response. It just exists, present and silent, a gentle witness to your life. And in that silence, there's something curious, something that makes you wonder. If starlight is so old, if it has crossed time and emptiness to find you, does it still belong to the star that made it? Or has it become something else now that it touches you? No one ever teaches you how to see the past with your eyes open, not in the way starlight demands. We grow up learning that light is immediate. You flip a switch and a room glows. You strike a match and shadows flee. But the light above us breaks that rule completely. It isn't fast in any practical sense. It's ancient and patient. It moves at the universe's speed limit, and still, it takes lifetimes to arrive. And when it doesn't knock. It doesn't announce itself. It just appears, like a memory you didn't know you had. The next time you glance at the night sky, consider this. Some of those tiny dots of light, the ones that seem like pinholes in the dark fabric overhead, might have originated during the time woolly mammoths walked the earth. Some light left its home before the Himalayas had risen, before the oceans took their current shape, before the air smelled like it does now. You are looking at fossils, made not of bone but of brightness. And unlike fossils, starlight isn't buried in stone. It's just hanging there, free, available, waiting. But that raises a strange question. How does light survive the journey? Space isn't empty in the way a room without furniture is empty. It's emptier than we can truly grasp. There's no air to carry it, no road to travel on, just sheer, silent vacuum. And yet photons cross it with no complaint, no fatigue, no loss of speed. This tells us something profound about light. It doesn't need company. It doesn't need support. A single photon, set loose in space, will go on forever, unless something stops it. That something could be a dust grain, a mirror, a planet, or your retina. It's easy to forget how strange that is. Most things degrade over time. They lose energy, change shape, wear out. Light, true, unbroken starlight, does not. That idea alone is almost unsettling. It's as if photons are immune to the same passage of time that we're bound to. They leave a star and just go. And we, beings so deeply tied to the ticking of clocks and the weathering of years, can only witness their arrival and marvel at how unchanged they are. Now think about what a star must endure to even produce that light. A star isn't a flame, though we often picture it that way. It's a fusion engine, an immense sphere of gas where gravity has squeezed atoms so tightly that their nuclei merge. Hydrogen, the simplest and most abundant element, is fused into helium, and in that process, a tiny fraction of the mass is converted into energy. That energy radiates outward, travels through layers of plasma, escapes the star's surface, and joins the parade of photons flowing into space. But here's something even more mind-bending. The light that you see from a star, the light that finally reaches your eyes, may have taken thousands or even millions of years just to escape the star itself. Inside the dense layers of a star, photons don't travel in straight lines. They get absorbed, re-emitted, scattered. It's like trying to leave a crowded room through a single door with thousands of people jostling for the same exit. The photon you catch tonight could have been born in a star's core before humanity ever planted a seed. So by the time it leaves the star's surface and begins its uninterrupted flight through the vacuum, it's already been through a kind of purgatory. It has struggled its way out of a blinding interior only to begin a serene, straight-line journey across space. That serene portion is the part we notice, but its history is far more chaotic. Every glint of starlight is both a survivor and a traveler. It's not just ancient, it's tested. This understanding shifts our relationship with the stars. They aren't just distant lanterns hung in the sky. They are forges, generators, alchemists turning the simplest element into brilliance, one collision at a time. And every photon they emit carries a signature, a fingerprint. We call that spectrum. And while we'll explore that in more detail later, the key idea is this. Starlight isn't just light, it's information. Encoded into its very essence are clues about the temperature, size, age, and even motion of the star that made it. So when you see a star, you're not just seeing a glow, or you're reading a story, a very old story, told in the language of waves and particles, and you, even as you rest now, are one of its readers. You don't need a telescope or a PhD to understand its beauty. Your body already knows what light means. Your skin knows warmth. Your eyes know color. Your instincts know that a brightening sky means morning, and a darkening one means night. Somewhere deep in our biology, starlight is already familiar. But then another question emerges quietly in the dark. If we can see these stars from so far away, what does that say about the limits of vision? About what it means to observe? We aren't just passive recipients of this light. Our perception completes the loop. Without a retina or a sensor or a mirror, that photon might have just kept going, maybe forever. But it stopped at you. It ended its journey here, on this night, in this moment. And yet, starlight doesn't always land in the eyes of astronomers. It lands on mountaintops, on rooftops, on the bellies of sleeping cats, on waves, on frozen lakes, on the eyelids of those dreaming below open skies. Its destination is not always deliberate. Sometimes it's a quiet accident, a casual grace, but perhaps that's what makes it so moving. The idea that something can travel for millennia and still arrive without expectation. What else in the universe works like that? There's a peculiar comfort in knowing that the light resting on your face tonight might have started its journey before your grandparents were born, or before language existed, or before this earth took its current form. That something so fragile, a single photon, could survive the collapse of empires, the drifting of continents, the extinction of species, just to arrive here without fanfare, is almost too poetic to believe. But it isn't a metaphor, it's physics, the truest kind of poetry, hidden in equations and silence. And still, we rarely stop to ask, what exactly is starlight? Not just what it represents, but what it is. Light, at its core, is electromagnetic radiation, waves made of electric and magnetic fields, oscillating in perfect harmony. It's a dance that doesn't need a stage. It travels through nothingness, needing no medium, no conductor. And the wavelengths of this dance determine what kind of light it becomes, from long, gentle radio waves to short, sharp gamma rays. The light our eyes can see is just a tiny slice of this spectrum, visible light, the narrowest window in a vast cathedral of unseen radiation. That sliver, red to violet, is all we know firsthand. Everything beyond it requires instruments, translations, interpretations. But stars don't limit themselves to what we can see. They pour out radiation across the spectrum. Infrared, ultraviolet, X-rays, each part carrying different secrets about the star's temperature, age, motion, and composition. It's as if each star speaks in dozens of dialects, but we only understand one, and even that imperfectly. Still, what we do see is enough to start asking deeper questions. Why are some stars red and others blue? Why does some seem to flicker while others hold steady? Color, in the language of starlight, is more than aesthetics. It's a thermometer. A red star is cooler, not cold, but burning at thousands of degrees rather than tens of thousands. A blue star is blazing hot, furious, young, and often short-lived. The hue of a star is not its style, but its state. And if you look long enough, you begin to see the sky not as a flat canvas, but as a layered time map, dotted with fires in different stages of their long, strange lives. Temperature explains color, but it also ties back to how stars behave. Cooler stars burn their fuel slowly, like a candle conserving wax. Hotter stars burn bright and fast, living short, dramatic lives before ending in explosive supernovae. And though all stars emit light, not all stars are equal in what they reveal. Some are generous with their radiation, others are cloaked, veiled by dust or distance or sheer faintness. There's starlight we'll never see, some of it absorbed by interstellar dust, some of it scattered away before it ever gets close, and some of it simply lost, bent by gravity, twisted by the warping of space-time, or swallowed whole by a black hole. But when light does reach us, when it threads the cosmic maze and touches Earth, we can do something extraordinary. We can split it. Using a prism or more sophisticated tools, we can break a beam of starlight into its component colors, like unraveling a tightly woven thread. And within that spectrum, within the rainbow it reveals, are tiny gaps, absorption lines, dark slivers where certain wavelengths are missing. They're not random, they're signatures. Each element, hydrogen, helium, oxygen, iron, absorbs light at specific wavelengths. So by looking at what's missing, we learn what's there. It's like reading a sentence where the missing letters spell the truth. This technique, called spectroscopy, allows us to know what stars are made of without ever touching them, without ever sending a probe. We read their fingerprints from light years away. It is perhaps the most elegant trick astronomy has ever learned, to study what is present by noticing what has been taken away. And all of this, the color, the spectrum, the light's intensity, comes to us freely, every night, unfiltered, unedited, uncensored. It's a quiet miracle, really. We don't pay for it. We don't have to schedule a time slot. We simply exist on the surface of a planet that orbits a star, tilted just right so that as it turns, half the world becomes a theater for light older than memory. We don't need to earn it. We only need to look up. And yet, most of us rarely do. Not really. Not for long. Cities flood the night with artificial brightness. Buildings crowd out the horizon. And above it all, we forget to notice what has always been there. Stars glowing not just in beauty, but in defiance of time and space. Still, in places where the sky remains dark, the stars can feel like a map. Not of places, but of time. A web of scattered embers, each one telling a version of the past. But even in those places, one mystery lingers more than the rest. A question too quiet to ask aloud, but impossible to shake once felt. How much of what we see is real, and how much is just a lingering echo? So that quiet tension between what is and what was hangs in the air every time you look up. It's a kind of cosmic uncertainty, the realization that your senses are always just a little too late. You see the stars not as they are, but as they were, and the deeper you stare, the older the light becomes. Some of the stars shining above may have already gone dark, collapsed into silence, turned to ash, and yet their light continues to drift, unaware that the fire is gone. It is possible, even likely, that some of the stars you think you know no longer exist. Their final pulses may have come and gone unnoticed, hidden behind the slowness of light's loyal journey. This disconnect is strange. On Earth, sight is immediate. You see someone smile, and it's happening now. A candle flickers, and the light registers almost instantly. But space undoes that intimacy. It stretches the timeline. Every observation becomes a form of archaeology. To see is to dig, to uncover layers, to travel backwards. This is not metaphor. This is the reality of light speed delay. And once you accept it, the sky changes. It's no longer a field of glittering decoration. It becomes a museum. Each point of light is an exhibit frozen in a particular time, placed at a distance not just in kilometers, but in years, decades, and millennia. The farthest light we've ever seen comes from galaxies so distant, their photons have taken more than 13 billion years to arrive. That's almost the entire age of the universe. When you stare at the deep field captured by a space telescope, you aren't looking at the edge of the universe, you're looking at its infancy. These are not galaxies as they are now, but as they were when the cosmos was still new, still stitching itself together. It's hard to hold that thought in the mind, that the farther you look, the younger the universe becomes. That darkness doesn't mean absence, it means distance, or perhaps delay. And this delay isn't just a curiosity, it's fundamental to how astronomy works. We don't observe the universe as it is. We reconstruct it, piece by piece, light by light. Each observation is a message intercepted. Each telescope is a time machine, and astronomers know this intimately, that the sky is not a present moment, but a layered mosaic of past events, all arriving at once, overlapping like the notes of a long-forgotten symphony. Even if a star exploded thousands of years ago, its final light may only now be arriving, painting the sky with a shimmer of farewell no one will recognize. This is why some stars surprise us. We see a steady twinkle one year and a sudden disappearance the next, and then, searching back through old data, we find the hints of a slow dying, a flicker, a dimming, a silent shift. But the actual moment of death, that already happened. We are just late to the wake. It's not a failure of science. It's a law of the universe. The speed of light isn't just a measurement. It's a barrier, a delay that protects the present from collapsing into the past all at once. And yet, for all its slowness, light is fast. It's the fastest thing there is. Nothing outruns it. Nothing moves through space quicker. And still, space is so vast that even light with all its speed cannot escape delay. Think of that. How enormous, how stretched, how open the universe must be for the fastest traveler to seem slow. It's like watching a bullet crawl across a continent or hearing thunder years after the lightning. If light feels slow, it's not because it's failing. It's because space is succeeding at being vast beyond comprehension. There's something philosophical buried in that. Something about how information works, how knowledge always trails behind events. We are creatures of the present, trying to piece together a story from scattered clues. But those clues are old. Even the sunlight warming your skin left the sun over 8 minutes ago. And if something catastrophic happened to the sun, if it vanished in an instant, we wouldn't know until 8 minutes later. We'd live in a false present, trusting in a light that no longer has a source. So much of life is like that, trusting what appears steady, not knowing if the cause is still there. It makes you wonder how much of your world is made of echoes. How many of the things you believe are still burning have already gone out? Not just stars, but people, feelings, certainties. And does that make their light any less real, or does it make it more sacred? Because that's the thing about starlight. It doesn't care whether its source still exists. It doesn't turn around to check. It just keeps moving forward, carrying its information, offering it to any eye or sensor that happens to be looking. It is loyal without memory. It travels without grief. If a star dies and no one is watching, the light still arrives. It still lands. It still means something. The universe, it seems, is full of messages that outlive their senders. And we, for our part, are full of questions we cannot ask fast enough. If you sit with that idea long enough, it begins to soften the way you think about reality itself. You begin to understand that everything you perceive, even the light around you, is a series of moments stacked one after another, never fully catching up with what caused them. You are always a little behind, always seeing the world as it was a fraction of a second ago, or, in the case of starlight, a lifetime or more ago. This delay is not just an inconvenience or a curiosity. It's a feature of the universe, a rule so deeply embedded in the structure of space and time that it shapes everything we know, from the way stars twinkle to the way galaxies evolve. And it isn't just stars that obey this rule. Everything that emits light, galaxies, nebulae, supernovas, even planets, is governed by the same limitation. If it glows, it travels, and if it travels, it takes time. So the image of the sky you hold in your mind, the star map you might have traced as a child, is a kind of time-laced tapestry. The patterns are not only spatial, they're chronological. Some of the stars that form familiar shapes, like Orion's belt or the Big Dipper, may have emitted their light during different eras entirely. Their alignment is as much an illusion of timing as it is of position. When astronomers build sky maps, they know this well. A snapshot of the heavens isn't a picture of now, it's a collage of countless thens, each one stitched together by photons arriving at Earth's orbit after lonely journeys. Some light left its home just as early civilizations began planting crops. Some even earlier, when Earth was still assembling its crust before air was breathable. You can hold that thought in your head as you lie in bed, that somewhere up there, light is just now reaching us from a star that was born when this planet was fire and stone. And even that idea is incomplete, because in truth, the starlight doesn't stop when it reaches your eyes. It continues. Your body catches it, registers it, but the photon doesn't simply vanish. It transfers energy, changes form, becomes heat, or sets off a chemical reaction in your retina. That faint tickle on your vision, that point of white or blue or gold, is your body interacting with something ancient. You are not just observing the past, you're absorbing it. This interaction makes every gaze upward a quiet act of communion. You are taking in remnants of events that happened far away, long ago. The death of a massive star, the stable pulse of a red dwarf, the breath of a galaxy you cannot name. And without effort, without ritual, your eyes become the final destination of that light. You become the archive, the witness. Whether or not you remember what you saw the next morning, the moment existed, the exchange happened. The universe arrived at your doorstep. And yet, for all its intimacy, Starlight remains silent. It doesn't come with instructions. It doesn't narrate its journey. It offers no clear message, only presence, which is why it has haunted humans for so long. We look at the stars and sense that they mean something, not just scientifically, but emotionally, as if they're telling us something too slow to decode, too vast to translate. This is why civilizations built myths around them, gave them names, made them gods and heroes. In the absence of voice, we gave them stories, and those stories helped us remember where the stars were, how they moved, what they might mean. But even stripped of mythology, even in the age of telescopes and spectrometers, the stars haven't lost their power. If anything, they've gained it, because now we know what they truly are. We understand the fusion at their cores, the radiation they release, the distances involved. We know that every glimmer above is a sustained explosion, balanced between gravity and the outward pressure, that what looks like a peaceful point is a nuclear fireball burning with unrelenting force. And yet, despite that violence, the light we receive is soft, gentle, cool to the touch. This is another paradox of starlight. Its origin is chaos, but its arrival is calm. Stars burn themselves apart so that you can read a book by candlelight. Their lives are fierce and short, or slow and grinding, but their light, when it finds us, is serene. You could almost forget what it cost to create it. That's the way of the universe. It hides effort behind elegance. It dresses violence in stillness. And maybe that's why starlight is such a perfect companion for the night, because it doesn't demand attention, it doesn't fill the silence, it honors it. You can lie back, close your eyes, and know it's still there, trickling down through the atmosphere, bouncing off rooftops and treetops, brushing against your skin even as you drift further from wakefulness. It asks nothing. It expects nothing. It simply arrives. But somewhere, deep inside the knowledge of its journey, you might feel a question begin to form, slow and quiet, like a breath beneath the surface. How does starlight remain so unchanged across all that time? How does it stay intact, honest, and bright? To understand how starlight keeps its shape across the ocean of space, you have to return to what light truly is. Not a thing you can hold, but a movement, a wave, a disturbance in the invisible fields that fill the universe. Electromagnetic waves, they're called. But that name, clinical as it sounds, contains a kind of beauty. It means light is a ripple that doesn't need water, a pulse that doesn't need air. Where sound would fall silent and matter would drift apart, light goes on. It rides the vacuum, riding nothing at all. Its persistence doesn't come from stubbornness, but from the very laws that define motion and energy. And because it has no mass, it is never slowed by friction or burdened by inertia. It travels at a speed that nothing else can touch, and because of that, it changes less than anything else in the universe. But that doesn't mean it changes nothing. As light moves through space, it stretches. Not because it's tired or fading, but because space itself is changing. The universe is expanding, not like a balloon blowing up from a center, but like a fabric being pulled gently from all sides. And as that fabric stretches, so does the light moving through it. A photon that began its journey with a short, energetic wavelength, say in the ultraviolet, may arrive as a longer, redder, gentler beam. This effect is called redshift, and it means the universe doesn't just age through the ticking of clocks, but through the lengthening of light. Redshift is more than a color change. It's a signature, a timestamp, a motion detector. When we see distant galaxies shifted toward the red, we know they are moving away. The farther they are, the faster they recede. This observation is one of the key clues that led us to discover the universe is expanding, not shrinking, not static, but growing, even now, even in this moment, while you lie still and breathe slow. And galaxies aren't just drifting apart. The space between them is growing. And the starlight that crosses that space gets stretched as a result, like ink on a balloon. This stretching is gentle but relentless. A photon doesn't notice it. It doesn't experience time or space the way we do. But we, as the receivers, see the change. The spectrum shifts, the energy drops, and yet the message survives. That is the marvel. Even altered, even redshifted, even dimmed by cosmic distance, the photon still arrives. It still tells us where it came from, how far it has traveled, and how the universe has changed along the way. It is a witness not just to the star that made it, but to the fabric of space it moved through. Think about that for a moment. Imagine shouting into a canyon and having your voice not just echo back, but return slower, softer, and warmer than it left you. Not because the air changed, but because the canyon itself stretched wider as your sound passed through it. That's what starlight experiences. It carries not just brightness, but the memory of expansion. And by reading that memory, the stretching of wavelengths, we can measure the age of the universe itself. Light becomes a kind of clock, not one that ticks, but one that stretches. The longer it travels, the redder it becomes. And because we know how much it should have stretched, we can rewind the cosmic film. We can trace backward, estimating how far and how long it must have traveled. This is how we discovered that the universe is about 13.8 billion years old, not by counting stars, but by measuring how far their light has shifted. And so, the sky becomes a storybook of expansion. Each star and galaxy is a letter, a word, a sentence composed not in ink, but in photons. Some of those sentences are clear, like a neighbor's voice through an open window. Others are faint, fragile, nearly drowned in noise, like whispers from across a crowded room. But all of them are there, written in the language of light, stretched by time, carried by emptiness, and finally arriving here, now, where you are. And this is where the metaphor deepens. Because if starlight stretches, if it is molded by the shape and flow of space, then it means space is not a stage, not something separate and passive. Space is dynamic. It breathes, it shifts, it carries consequences. It's not just where things happen, it is one of the things that happens. And light, being the most sensitive traveler, responds to every twist and swell. It is the thread that traces the movement of the loom. Even gravity can bend it. A photon, which has no mass, can still have its path curved by gravity. This is called gravitational lensing. It means that when light from a distant star or galaxy passes near something massive, like another galaxy or a black hole, its path bends like light through a lens. This bending can magnify the source, distort it, or even create multiple images. Sometimes you'll see a single galaxy appear as a ring or a smear in the sky, not because it is shaped that way, but because its light has been bent around an invisible mass. This effect is not just beautiful, it's useful. It allows us to see objects that would otherwise be too faint, too far, or too hidden. It reveals the presence of things we cannot see directly, like dark matter. And it's yet another reminder that starlight is not merely decoration. It is a tool, a guide, a bridge between what is and what can be known. And through all of this, redshift, lensing, expansion, one thing remains constant: the photon's journey, its trajectory, its mission. It leaves the star without hesitation, crosses the cosmos without complaint, and arrives without announcement. It is loyal to its path, even when the path is curved or stretched or obscured. It adapts, it continues, it delivers. So now, lying in the dark, you might wonder if starlight can survive so many changes, if it can travel across billions of years and still carry meaning. What else might be out there, still traveling, still searching for a place to land? There's something humbling about knowing the universe is full of light that hasn't reached us yet. Photons in motion, en route from distant stars and galaxies, still hundreds, thousands, even billions of years away from brushing against Earth. Each second, more of this light is entering our sky, becoming part of the dome we look up at, unaware that the image has changed ever so slightly. The stars seem fixed, but their light is not. New arrivals stream in continuously, quiet and invisible, filling in gaps, overlapping old waves, subtly updating the cosmic portrait. And because the distances are so great, that portrait will never be complete. There's always more coming, always more waiting. This unending flow turns starlight into something more than just a signal. It becomes a record of everything that ever burned. Not just the brightness, but the breath of stars. Their rhythm, their fluctuation, their character. Not all stars shine the same way, and some do not shine steadily at all. In fact, many stars vary in brightness over time. These are called variable stars, and they have their own kind of language, a pulse, a pattern, a beat that tells astronomers about what's happening inside them. Imagine a star that expands and contracts like a lung, growing brighter and dimmer in a predictable cycle. These pulsating stars, like the famous Cepheids, are not just astronomical curiosities. They are rulers for measuring the cosmos. Because their brightness changes in a known way, scientists can compare how bright they appear from Earth to how bright they truly are, and calculate how far away they must be. These flickers, barely perceptible to the naked eye, are the measuring sticks of the universe. Other stars vary because they are not alone. They are part of binary systems, pairs of stars orbiting each other, one passing in front of the other as seen from Earth. When one blocks the light of its companion, the total brightness we observe dips slightly like a blink. These eclipsing binaries tell us not just about distances, but about masses, sizes, orbits. We read their light as you might read the shadow of a turning wheel, interpreting the shape and spacing of dips and rises. There are also stars that flare unexpectedly, exploding with sudden energy before returning to calm, and others, near the end of their lives, that throb with irregular light, releasing gas into space, forming the seeds of future solar systems. Each variation in starlight is a clue, a behavior, a symptom, and each star, in its flickering or pulsing, is trying to tell a story about its internal structure, its age, its past, and its fate. Even supernovae, the cataclysmic deaths of massive stars, begin with light. When a star collapses, it releases a final, spectacular burst of brightness, often outshining an entire galaxy for a few days. That light, which travels at the same steady pace as any other, can cross the vastness of space, and one day, quite unexpectedly, appear in our telescopes or in the corner of a photograph. A sudden light, blooming in a place where no star was seen before. By the time we see it, the explosion is long over. The debris is expanding, the star is gone, but the light is here, and it speaks for the event that once was. And light is not the only thing that travels from such deaths. Sometimes particles, neutrinos, cosmic rays arrive too. Sometimes gravitational waves ripple through space itself, a trembling in the geometry of the universe caused by collisions far away. But light is the first to be seen, always the first, always the most immediate messenger, the one that paints the picture. That picture, when carefully studied, offers not just snapshots, but timelines. Through careful measurement, astronomers can map how a star's brightness has changed over time. They can determine if it's spinning fast or slow, if it's swelling with age or shrinking with gravity, if it's alone or accompanied. Starlight becomes a medical chart, a biography, a confession, and with enough time and attention, a single point of light can unravel a life story written over billions of years. It's worth pausing to consider that that we know so much about stars we'll never visit, never touch, never hear, simply by watching their light. We have no samples, no artifacts, just photons. And yet, from those alone, we've learned the elements of stars, their temperatures, their velocities, their distances. We know if they're coming closer or drifting away. We know if they're spinning. We even know how long they've been alive and how they'll die. And all of this from waves and particles that travel through space, pass through clouds, slip past satellites and cities, and land silently on our instruments or on our eyes. It makes you wonder how much more information is out there, hidden in the signals we've yet to read. How many stars are blinking in ways we haven't noticed? How many messages are buried in the timing of those flickers? Because light, even when it's steady, contains within it so many layers: color, brightness, shift, spectrum, polarization. Every one of these properties so carries data, and each one tells a slightly different part of the story. Together, they weave a full picture, but separately, each is its own thread, waiting to be noticed. And if a single star can hold that much complexity, what does that say about the entire sky? What does it say about the ocean of light that surrounds our planet every night? Could it be that we're not just under a sky, but inside a library? If the night sky is a library, then every star is a book, and every beam of starlight a page drifting slowly toward us through time. But unlike any library on Earth, this one is self-writing, constantly updating, never fully read. We don't have to climb shelves or search catalogs to explore it. We just have to look up. And the act of looking is enough to begin the reading. The eyes become telescopes. The mind becomes a translator. And without needing to touch a single thing, we learn the composition of suns 1,000 light years away. It's remarkable when you think about it. We know what stars are made of, not because we've been there, not because we've captured samples, but because of the fingerprints their atoms leave on light. When light passes through the outer layers of a star, some wavelengths are absorbed by specific elements. These missing pieces show up as dark lines when the light is spread out into a spectrum, and each element creates its own unique pattern of these lines. Hydrogen leaves a certain arrangement, helium another, oxygen, carbon, iron, all have their own spectral signatures, like musical notes played by invisible hands. This technique, spectroscopy, is the backbone of stellar chemistry. It tells us not just what a star is made of, but how much of each element is there. We can even tell the temperature from how wide or narrow the lines are, or the density of the atmosphere from how sharp or fuzzy the details appear. It's like hearing a song from another room and being able to identify not only the instruments, but also the shape of the hall, the weather outside, and the age of the piano. And this works not just for stars, but for galaxies, for quasars, even for planets orbiting distant suns, all because light is generous with its details. And those details don't just speak about the stars themselves, they whisper secrets about the earliest times. Some of the most ancient light we observe is still glowing from a time when the universe had no galaxies yet, no stars, no planets. Only hydrogen and helium drifting through expanding space. When we study light from those times, we're not just learning about distant places. We're looking into our own origins. Because the same hydrogen that filled the young universe now flows through your veins. The same carbon forged in the hearts of dying stars now supports your cells. The same iron that pulses in your blood was once the core of some other world, long gone. To say that we are stardust is no longer poetry. It is a statement of chemical fact. The elements that compose your body, your muscles, your thoughts, your memories, were all made in stars, born in fusion, scattered in death, reassembled by time. Some came from gentle red giants, others from catastrophic supernovae, and somewhere along the way enough of them found each other and settled into a new planet, around a new star, and eventually into the body that now lies resting beneath a soft sky. This means that every time you look up, you're seeing a reflection of your own past, not metaphorically, but materially. You are composed of the same light-carved elements that now flow toward you from above. The calcium in your teeth, the oxygen in your breath, the carbon in your bones, all of it once passed through a furnace of stellar fire. You are not a separate observer of the cosmos. You are its continuation, a part of it, briefly organized into thought and feeling, capable of looking back at the place you came from. And this perspective reframes everything. Starlight isn't distant anymore. It's intimate, not just something to admire, but something to recognize. You and the stars are built from the same fabric, shaped by the same forces. The gravity that holds your feet to the ground is the same that holds galaxies together. The atoms that fire in your brain are tuned by laws that govern neutron stars. The difference between you and a star is not kind, but degree, density, temperature, context. This is what makes starlight feel so quietly profound. It doesn't just illuminate the night, it connects you to everything beyond the night. It turns the darkness above into a bridge, and the silence into a signal. It's not shouting, it's not preaching, it just keeps arriving, soft and steady, carrying ancient information across unimaginable distances, offering it freely, waiting for someone to notice. And when you do notice, when you stop, breathe, and truly look, you might feel a flicker of something deeper. Not emotion, not awe. Something quieter, a settling, a recognition. The sense that you are not small, not lost, but appropriately scaled. A creature of time and matter, alive during the moment when the universe learned to look back at itself. So the next time you see a star, try to remember, you are not just looking at it, you are reading it, listening to it, holding in your eyes the evidence of fusion and distance and death and rebirth. And maybe, in that gentle, distant light, you can also read something about yourself. Because if stars can be born from clouds of gas, burned for billions of years, and then scatter their elements across the cosmos, only to have those elements come together again in the form of a conscious, breathing body, then what else might be waiting in the starlight we've yet to receive? The idea that something as complex and alive as you could emerge from the remains of stars is easy to dismiss at first, too abstract, too poetic to feel practical. But the science behind it is as concrete as gravity. Stars are not merely ornaments in the sky. They are factories, element forges, engines of creation. In the beginning, the universe was simple. Just hydrogen and helium and a touch of lithium, light elements drifting in the expanding void. No planets, no people, no complexity. But then came the stars, drawn together by gravity into dense, hot spheres, where fusion lit the fires that would change everything. Inside those stellar cores, atoms began merging. Hydrogen became helium. Then, in larger stars, helium became carbon, then oxygen, then silicon, and eventually iron. Each fusion step released energy, fueling the light you now see. But once a star reaches iron, it can no longer produce energy through fusion. That's where its story begins to end. And it is in that end, in the violence of a supernova, that something new happens. The star tears itself apart, scattering all the elements it created into space, mixing them with interstellar dust, seeding the galaxy with raw materials for the next generation of stars, and eventually for life. This cycle, fusion, explosion, dispersal, has played out billions of times. It's still playing out now in places your eyes cannot see, in light your body cannot feel. The universe is not done with creation. Even now, clouds of gas are condensing, collapsing under their own gravity, igniting into new stars. And around these new stars, disks of debris swirl and clump, forming planets, moons, asteroids. One of those planets, long ago, became Earth, and the elements that had once floated as vapor inside stars came together in new ways, into oceans, rocks, DNA. You are living proof that starlight doesn't just illuminate, it assembles, it shapes. The photons that pass through your skin are distant cousins of the energy that helped form your very molecules. That connection isn't mystical, it's physical. It means when you close your eyes and feel the heat of sunlight on your face, you're feeling a continuation of the same processes that began with the first stars. The atoms in you are old, some older than Earth itself, and yet they move through you now, arranged in new patterns, performing thoughts, building memories, dreaming dreams. It's a slow kind of magic, governed not by spells, but by time and law and pressure. Stars don't just shine, they labor. For millions or billions of years, they convert mass into light, patiently crafting the ingredients needed for everything we call living. Then, in the final act, they scatter those ingredients across the universe, where gravity and chemistry pick up the story. Life, in all its fragile, improbable elegance, is the universe's way of recycling its own brilliance. It gathers starlight and folds it into flesh. And so when you breathe, you're not just filling your lungs with air, you're participating in the rhythm of something much older. The oxygen you draw in may have originated in a red giant long gone. The iron in your blood may have been born in a supernova that burned brighter than an entire galaxy. You carry that history in every cell, though you don't feel it. But the stars do. They've marked you. They've written themselves into you. And now, in the stillness of night, they shine that same light back toward you, as if checking in. This is why stargazing feels so personal, even when you're surrounded by silence. You're not just looking out, you're remembering. Your body knows these frequencies. Your atoms have felt them before. It's not nostalgia, it's recognition. A kind of ancestral memory buried in matter itself, triggered not by words, but by wavelengths. And if all this is true, then it means something else equally profound. That light is not just a way of seeing the stars. It's a way for the stars to return to us. Every photon is a handshake, a reminder, a spark from the fire that forged the building blocks of thought. The sky isn't distant, it's woven into you. You are not beneath the stars, you are among them. So the next time you lie awake, caught between waking and sleep, watching a single point of light flicker through the curtains or reflecting off a window pane, know that you are not looking at a stranger. That light may be older than every book, every city, every name, and yet it lands softly, gently, without effort, as if it always meant to find you. And if that's true, if light knows how to cross such emptiness, to survive so long and remain so clear, then maybe nothing is truly lost. Maybe everything that burns leaves behind some trace, some warmth, some echo waiting to be found. Light never rushes, and yet it is always on time. It does not hurry across the cosmos, but it doesn't hesitate either. When you consider the age and scale of its journey, from the death of stars to the curve of your retina, the patience of starlight becomes almost spiritual. But long before it can reach us, before it ever becomes the gentle glow through your window or the shimmer behind your dreams, starlight must first be born. And its birth is not quiet. It begins in the coldest places in the universe, vast clouds of gas and dust, places so dark and dense that not even background starlight can penetrate them. These are the star nurseries, and they are nothing like what you'd expect. Not hot, not bright, but silent, still, waiting. Within these clouds, some dozens, even hundreds of light years across, tiny ripples of gravity begin to gather matter inward. It's not dramatic, it's slow, like snow drifting silently into valleys, like sand settling in a jar. Over thousands or millions of years, small knots of gas become denser. Their own gravity tightens the hold, pulling in more material. And as the mass increases, so does the pressure at the center. With pressure comes heat. With heat comes ignition. Eventually, deep inside that cocoon of gas, the temperature reaches a point where nuclear fusion can begin, and a star is born. But the light doesn't escape right away. For a long time, the forming star remains hidden, swaddled in its dusty veil. It shines only in infrared, a kind of invisible warmth. Telescopes on Earth and now in orbit can detect these embryonic stars, glowing gently in their dark wombs. They are not yet full members of the cosmos, not yet the bright dots we wish upon, but they are alive, forming, preparing. Their light is not for us yet. It is still struggling to be free. Eventually, as fusion stabilizes and the outward pressure balances gravity's inward pull, the star clears its surroundings. The radiation it produces pushes away the dust, the heat blows open channels, and the light finally escapes into open space. That first light, that birth cry of a star, may travel for thousands of years before reaching any other eye. And when it does, it's no longer a newborn. It is a light that has lived through generations of our own history, finally making itself known in a sky already crowded with ancestors. And stars don't form alone. Most are born in clusters, sometimes in the hundreds or thousands, all within the same region of a nebula. Some of these companions will become binary pairs, forever orbiting each other in a gravitational dance. Others will drift apart, flung by momentum and time, each carrying the elemental fingerprint of the cloud they came from. We can trace their origin by the elements in their spectra, like identifying siblings separated in infancy. These stellar nurseries are not rare. They exist throughout our galaxy and in others, quietly shaping the future. The Orion Nebula, visible even through small telescopes, is one such region. It's not just beautiful, it's active, teeming with newborn stars, disks of dust, and jets of gas being flung out at incredible speeds. In these environments, new solar systems begin to take shape, not just stars, but planets, moons, comets, and potentially the first steps toward life. Because where there is light, there is energy, and where there is energy, complexity can emerge. The starlight we see tonight may be illuminating not just other worlds, but other beginnings. It's not enough to think of stars as lonely points of light. They are hubs, centers of activity. Every star you see could be accompanied by dozens of planets, each one orbiting in a delicate balance, each one experiencing that starlight, not as a distant twinkle, but as a blazing central presence. Somewhere, maybe, there's another Earth, turning beneath another sun, wondering if they too are alone in the dark. That possibility is no longer fantasy. It is science. Thousands of exoplanets have been discovered, most of them detected not by direct imaging, but through subtle changes in starlight. When a planet passes in front of its star, it blocks a tiny fraction of the light, causing a momentary dimming, a small drop that our instruments can detect. From this, we can infer the planet's size, its orbit, even hints about its atmosphere. Starlight becomes a way not just to see stars, but to see what orbits them. It becomes a spotlight, revealing shadows. And this means that from the birth of a star to the formation of planets around it, starlight is a constant thread. It emerges from the chaos of gas and dust. It escapes into the void. It travels through gravitational fields and across cosmic expansion. And it lands here, in your vision, or in the eye of a telescope, or in the dim memory of a night you once spent lying on a rooftop, trying to count what could never be counted. The stars being born now will still be shining long after this moment is gone. They will outlive us, outshine our cities. They will still be radiating long after every light on Earth has gone out. And their light, crossing vast distances in the dark, may someday touch other worlds, other minds, other resting bodies beneath unfamiliar skies. So the next time you look up, remember that not all starlight is old. Some of it is young, newborn, just beginning its long, patient journey through space. Maybe it's already on its way to you. Maybe it's still tangled in dust. Maybe it's still fighting to be free. And while most stars beam steadily across the eons, offering a dependable glow in the night, not all starlight is so composed. Some stars flicker, others pulse, some flare up without warning, casting out sudden bursts of radiation before settling back into silence. And some vanish altogether, their light disappearing from the sky as suddenly as it once appeared. These changes are not random. They are rooted in physics, in the restless interior workings of stars, in the tug-of-war between gravity and heat, mass and time. In these variations, the stars reveal more than just brightness. They reveal behavior. Among the most captivating of these are variable stars, stars whose light waxes and wanes in cycles so predictable that entire galaxies have been measured by their rhythm. The Cepheid variables, for instance, are stars that expand and contract in a steady rhythm, growing brighter and dimmer with such regularity that they've become cosmic yardsticks. By comparing their apparent brightness to their true brightness, which is directly linked to the period of their pulsation. Astronomers can calculate their distance. These stars are more than flickering points in the sky. They are rulers drawn across space, helping us understand just how far away things really are. But not all flickers are periodic or smooth. Some stars experience sudden outbursts, flares of light, UV bursts, X-ray emissions. These can be caused by magnetic disturbances, by surface eruptions, or by interactions with companion stars. And sometimes, the companion is more than just close. It's consuming. In certain binary systems, a white dwarf star draws in material from a nearby companion, stealing its gas until the pressure builds and triggers a nova, a sudden, temporary brightening that can outshine all nearby stars for days or weeks. And if the mass grows too much, the white dwarf may collapse entirely, producing a type Ia supernova, a brilliant, catastrophic explosion that leaves nothing behind. Other stars die in more solitary grandeur. Massive ones, far more massive than our Sun, burn through their fuel quickly, their cores becoming unstable. When the balance between outward pressure and gravity collapses, the star implodes, then rebounds in a violent explosion, a core collapse supernova. For a brief moment, the star may radiate more energy than all the other stars in its galaxy combined. That light races outward, carrying information about the elements created in the explosion, about the final state of the star, and about the shock waves sent rippling through surrounding space. And sometimes, the collapse is so complete that even light cannot escape. A black hole is born. But even in this finality, there is starlight. Just before the event horizon is crossed, that boundary beyond which no information can return, matter spirals inward, heating to incredible temperatures and emitting vast quantities of radiation. We can't see the black hole itself, but we can see what falls into it. We can measure its mass, track its pull, and observe how it bends light from the stars behind it. Even in disappearance, there is visibility. Starlight can also be bent and duplicated. In a phenomenon called gravitational lensing, the light from a distant star or galaxy passes near a massive object, another galaxy, or a cluster, or a black hole, and is curved by the gravity of that mass. This bending of space causes the light to reach us along multiple paths, creating distorted, magnified, or even multiple images of the same object. Sometimes, we see a ring of light where a single galaxy should be, an Einstein ring, caused by perfect alignment between source, lens, and observer. The effect is beautiful, but more importantly, it's informative. It allows us to see objects too faint or distant to observe directly. It reveals the invisible, including dark matter, which we cannot detect through light, but which warps the light of other things. These distortions are not imperfections. They are data. Every flicker, every shift, every ripple in starlight is a clue. To a scientist, the sky is never still, even on the clearest night, when the stars appear serene and motionless. They are changing. They are telling stories. Not in words, but in frequency and flux, in pulse and profile. And for those who know how to listen, there is no end to what they can say. Starlight is not just information, it's motion. When a star moves toward us, its light is slightly compressed, shifted toward the blue end of the spectrum. When it moves away, the light is stretched, shifted toward the red. This Doppler effect, allows astronomers to measure the velocities of stars, to detect the wobble of a star caused by the gravity of an orbiting planet. It even lets us hear the breathing of stars, their internal oscillations reflected in subtle modulations of light. This is called asteroseismology, and it's one of the most delicate sciences imaginable. By measuring tiny variations in a star's brightness, scientists can infer the structure of its interior, its composition, even its rotation. We do this from light alone, from a single unwavering stream of photons that has crossed the galaxy to land on a detector, or perhaps on your closed eyelid as you lie still, wondering what these lights are really saying. It's even the dimmest star has a voice, a frequency, a rhythm. We are only just beginning to understand how to listen. And so the sky, which once seemed like a gallery of perfect, unchanging dots, becomes something else, a living sheet, a vibrating membrane stretched across space and time, trembling with energy, warped by gravity, filled with flickers and fades and echoes. It is not quiet. It only seems that way. And if the stars have moods, if they breathe, if they blink, then what does it mean to call them eternal? Maybe eternal is the wrong word. Maybe stars aren't meant to last forever, not as individual objects, but their light, their echoes, their fingerprints, those persist, and in the silence left behind, we begin to notice something else. Not all that shapes the universe shines. In fact, most of it doesn't. For every star we see, there are countless invisible hands moving behind the curtain, bending light, steering galaxies, sculpting the cosmos without a single flash. The more we study the stars, the more obvious it becomes. There's far more out there than we can see. Starlight, so for all its honesty, is only a fraction of the full picture. Consider dark matter. It does not emit light. It does not absorb light. It does not reflect or scatter or flicker, but it is there. We know it because of the way light bends around it. Galaxies spin in ways that don't make sense unless there is more mass than we can account for. Clusters of galaxies hold together with a grip stronger than visible matter alone could explain. The paths of stars, the shapes of galaxies, the lensing of distant starlight, all of them whisper the same truth. There is something massive and invisible everywhere. Dark matter. We can't see it directly, but we see what it does to starlight. And then there's something even stranger, dark energy. Unlike dark matter, which pulls with gravity, dark energy pushes. It drives the acceleration of the universe's expansion. For years, scientists thought the expansion of space must be slowing down, like a ball tossed upward. But when they measured the light from distant supernovae, explosions so bright they can be seen across billions of light years, they found something unexpected. The redshift was too strong. The light was stretched too far. The expansion was speeding up, and the only explanation that fits is a force we can't see, can't touch, and barely understand, but which comprises most of the energy in the universe. So here we are, drifting in a sea of starlight, surrounded by forces that don't glow. The visible universe, the stars, the galaxies, the light, makes up only about 5% of everything that exists. The rest is dark. Not evil, not ominous, just unlit, just unseen. And that means that even the most radiant star is not the full story. It's a clue, a surface ripple, a shimmering on the top of a vast and shadowed ocean. But starlight, limited as it is, can still help us peer into the dark. When light passes through the cosmos, it is influenced by everything it encounters. The way it bends, slows, stretches, or shifts tells us what's nearby. Even if we can't see the thing itself, we can read the traces it leaves in the light that passes by. It's like watching leaves swirl in a river and deducing the shape of the stones beneath. The patterns in starlight are never random. They are maps. This is why astronomers now search for subtle distortions, faint alignments, tiny delays in the arrival of photons. They're not looking at the light alone. They're looking at what it passed through, what slowed it, what pulled it off course. In these variations, they're finding evidence of invisible structures, filaments of dark matter threading the universe together, halos around galaxies, and voids so immense that entire clusters vanish from view. Light is their only guide, and yet it's enough. It's always been enough. Even cosmic background radiation, the oldest light in the universe, tells us something about the dark. This faint microwave glow, discovered almost by accident in the 1960s, comes from a time just 380,000 years after the Big Bang. Before that moment, the universe was too hot and dense for light to travel freely. But when it cooled enough for atoms to form, photons decoupled from matter and began their long journey. That ancient light still surrounds us, uniform in all directions, cooled by the universe's expansion to a few degrees above absolute zero. This light is not from stars. It predates them. It comes from a time before galaxies, before planets, before even the first atoms of carbon and oxygen. And yet it exists. It fills the sky, unseen by human eyes, but detectable by microwave telescopes, like a soft hum soaked into the fabric of space. Its tiny variations, minute changes in temperature and density, are the seeds of everything that followed. In those variations, the early structure of the cosmos was written, and in the way that ancient light has been stretched and pulled across time, we find the fingerprints of dark energy itself. So starlight, though it seems like the main actor, is also a witness. A record, it shines, yes, but it also reveals what doesn't. It shows us not only the stars that burn, but the scaffolding they cling to. It speaks for the spaces in between, for the vast, quiet presence of the dark. And that realization leads somewhere deeper, to the understanding that what we don't see, what we can't detect with our eyes, may matter even more than what we can. The darkness between the stars is not empty. It is full of gravity, of tension, of possibility. And starlight, fragile and fleeting though it seems, is what allows us to trace the outline of that fullness. So the next time you gaze into a sky speckled with stars, remember that what you see is just a sliver, a glimmer, a thin layer floating atop something deeper. And if even that thin layer can carry such wonder, if even a single photon can tell the story of 1 billion years, then what stories still wait in the dark, untouched by light, waiting for someone to find them? Sometimes, when you stare long enough at the stars, it doesn't feel like you're looking out. It feels like the universe is looking back, that somewhere beyond those pinpricks of light, there's another gaze, another presence, wondering the same thing you are. Is anyone else out there? It's a question older than language, written into the earliest stories, carved into temple walls, and whispered into the silence of deep space missions. And now, Science has begun to ask it, not just with wonder, but with tools. And the tool it returns to, again and again, is starlight. Because if we were to find other life, intelligent life, the first sign might not be a signal or a voice, but a change in light, a slight dimming that follows a strange pattern, a spectrum that contains unnatural chemicals, a pulse too regular, too deliberate to be random. Light is not just how we see the stars, it is how we might see minds not other than our own. This is why astronomers study exoplanet atmospheres. When a planet passes in front of its star, some of the starlight filters through its atmosphere before reaching us. That thin veil imprints itself on the spectrum, revealing what gases are present. Oxygen, methane, water vapor, these are not just chemical facts. They are hints, possibilities, signs that something complex, perhaps even biological, is unfolding on a world too distant to ever reach. If we detect such a signature, we might not hear music or see cities, but we'll see starlight changed by life. There are even stranger possibilities. What if another civilization, far older than ours, used light as a signal? Not radio waves, which are common, but messy, but tightly focused beams of visible or infrared light, lasers, fired across the cosmos with purpose. We've begun searching for these, scanning the skies not just for stars, but for signals embedded in their light. Beams that flicker in patterns no natural object would make. A cosmic lighthouse, sending out pulses in prime numbers or Fibonacci sequences. It might not be a message in words, but it would be a message, and perhaps one day we might respond, not with rockets or rovers, but with light of our own. Lasers fired toward distant stars, not as weapons or tools, but as greetings, invitations, proof that we are here, that we have seen and learned and reached the point of looking outward not just with curiosity, but with intent. Our first interstellar conversation may be made not of voices, but of photons. Even now, in a quiet way, Earth is already sending out light, not just from our sun, reflected off oceans and clouds, but from our technology, satellites, cities, telescopes, all adding to the planet's glow. An alien observer, watching us from a nearby star, might already see the signs. A planet wrapped in oxygen and nitrogen, dotted with artificial lights, brimming with activity. They might not know our stories or languages, but they'd know we're here. They'd know we are beings who interact with light. And this is perhaps the greatest testament to Starlight's power, that it doesn't just show us what's out there. It shows others what's here. Our planet, in all its blue and green and gold, is part of the cosmic mirror. And as we read the sky reads us back. We are part of its reflection. This reciprocal gaze, this mutual visibility, is where astronomy becomes something more than science. It becomes communion. The stars are not merely subjects of study. They are participants in a silent dialogue where the language is light and the message is time, and each observation, each measurement, each new photon caught by a lens or a mirror deepens that dialogue. But we are not only asking about others, we are also asking about ourselves. When we search for life, we are really searching for context. Are we alone? Are we early? Are we rare? Or are we simply one chapter in a much larger story written across thousands of worlds lit by 1,000,000 suns? We don't know. Not yet. But every part of that question runs through Starlight. And that's why we keep watching. Not just for patterns or anomalies, but for perspective. The stars show us what's possible. They remind us that the laws of nature are not local, they are cosmic. The same fusion that lights our sun lights every star we can see. The same gravity that holds your body to your bed holds galaxies together. The same chemistry that animates your thoughts may be at work right now on some distant moon beneath an alien sky. It may be centuries before we know for certain, or it may be tomorrow. One telescope pointed in the right direction, one spectrum line out of place, one blink of light that shouldn't be there, and everything changes. We'll know we're not just observers in a quiet universe, but participants in something shared. And when that happens, it won't come with a fanfare or a breaking news alert. It will come quietly, as Starlight always does, patient, ancient, honest. So tonight, as you lie there, your eyes growing heavier, your breath slowing, imagine a photon leaving some distant world right now. Maybe it's from a sun like ours, maybe it's artificial, maybe it's a mistake, or maybe it's a greeting. It begins its journey across space, unknowing, unguided, and one day, perhaps decades or centuries from now, it will touch something, a mirror, a detector, a retina, and in that moment, the universe will have introduced two strangers across light years of silence. What would we say if light could carry our thoughts? Perhaps we'd say nothing at all. Perhaps just the light would be enough. The act of sending it, of bending it, of shaping its path. Because in the end, starlight isn't just what we observe, it's also what we shape, what we use, what we create. Once we only received light passively. We watched stars rise and set, marked seasons by their cycles, mapped our myths into the constellations. But now we've begun to direct it, to bend it to our will, to weave it into the very fabric of our technologies. Light, it's no longer only the message. It is also the medium of how we communicate, connect, and explore. Fiber optics carry pulses of light across oceans, through cities, under our feet. Each flicker of laser inside those glass strands contains a cascade of information, thoughts, memories, pictures, voices, all transformed into tight beams of light, traveling through matter faster than we could have imagined just a century ago. What once took days to send across continents now takes milliseconds, and it's all because of the obedience of photons. They go where we aim them, reflect where we command them, carry what we choose to encode. And in the world of science, we have turned starlight's cousin, the photon, into one of our most powerful tools. Lasers slice through steel, read data off disks, perform surgeries on the eye. Telescopes now use laser beams to correct the distortion of the atmosphere itself, creating artificial stars to recalibrate their view, ensuring that what they see in the cosmos is as sharp and unblurred as possible. Light is no longer just illumination, it is precision, control, insight. We are not just receivers anymore, we are sculptors of light. Consider how we've built machines that gather light, not just to see far, but to look inward. MRI scanners, powered by electromagnetic radiation, let us glimpse the architecture of the brain. Infrared cameras reveal the heat signature of living bodies, of flowing rivers, of planets warming under distant suns. Ultraviolet lights unveil fingerprints, bacteria, hidden structures. We are surrounded by a spectrum of light that our eyes can't see, and yet we've built instruments to stretch our senses into those unseen realms. And then there are the telescopes, the great mirrors pointed skyward, drinking in light from galaxies so distant their glow began when Earth was still a molten rock. These instruments don't just magnify, they extend our reach. With them, we've seen back in time, past the formation of stars, past the birth of galaxies. We've stared so far into the deep field that we've caught a glimpse of what the universe looked like when it was only a few 100 million years old, a toddler burning with new stars and glowing clouds of gas. We are now designing spacecraft that will use starlight itself to travel. Solar sails, immense ultra-thin sheets of reflective material, are being tested as propulsion systems. The idea is simple but elegant. Photons have no mass, but they carry momentum. When they bounce off a surface, they transfer that momentum, gently, persistently. Over time, with enough surface area and enough light, a solar sail can accelerate without fuel, pushed by nothing more than the steady pressure of starlight. It's a kind of cosmic wind, a force so faint it can't be felt by your skin, but persistent enough to move a vessel across interstellar distances. And so light, once only a messenger, becomes a sail, a way to go, a way to travel, a way to explore beyond the reach of rockets and chemical engines. The very thing that told us about the stars may someday take us to them. Even in our cities, surrounded by artificial light, we are playing with starlight's principles. We reflect, scatter, refract. We design lenses that mimic the curvature of telescopes, microscopes, and camera sensors. Our screens emit carefully engineered spectra designed to match daylight or simulate candlelight. We build entire environments tuned to our circadian rhythms, adjusting brightness and color temperature to trick our bodies into feeling awake or asleep. We use light to influence the brain, to set the pace of our days, to shape mood and behavior. And this brings us back to something simple, something quiet. In all these uses, all these tools and innovations, we're really just continuing the same story. The story of starlight as our first guide, our first companion, the thing that helped us mark time, track movement, measure distance, and eventually understand where we are in the universe. Because even as we bend light and ride it and send it across the void, we are still learning from it. Every laser, every reflection, every data stream is a small echo of a much older signal, of the light that first arrived without permission or request, that simply came, offering information about something burning far away and asking only to be seen. So when you hold your phone and watch a video, or when you look through a microscope and see a living cell lit from beneath, or when you turn on a lamp to read a page at night, remember that you are working with the same substance that traveled from Alpha Centauri, the same particle that slipped past a supernova, the same wave that cooled from the fireball of the Big Bang. Light does not change its nature based on our use of it. It is always just itself, and in that, it becomes whatever we need. And yet, amid all our cleverness, all our mirrors and lenses and coded pulses, starlight still finds its way in, through the cracks in the blinds, across the curve of the horizon, reflecting off the eyes of someone staring up in the early hours of morning. No matter how much light we create, the original light still matters. It still reminds us. So maybe the most extraordinary thing about starlight is not how far it travels, or how much it tells us, or even how we've learned to use it. Maybe it's simply that after all this time, after billions of years and countless collisions and impossible distances, it still finds us. And if it does, what else might be trying to find its way to us, riding quietly along the same beams? There is one kind of starlight, older than all the rest, light so ancient, so faint, that it doesn't even come from stars. It comes from before the first star ever formed, from a time when the universe was still a dense, glowing fog. This light is not visible to the human eye. It is microwave radiation now, stretched thin by the expansion of space over nearly 14 billion years. And yet, it is everywhere. It saturates the cosmos, filling every corner with a faint yet persistent whisper. It is the cosmic microwave background, the afterglow of creation, the light from the moment the universe became transparent. Before that moment, the universe was opaque. Photons couldn't travel freely. They were constantly absorbed and scattered by the hot plasma filling space. But around 380,000 years after the Big Bang, temperatures dropped enough for electrons and protons to combine into neutral atoms. Suddenly, light could move unhindered, and it did. Those first photons, released into a newborn cosmos, have been traveling ever since. They are still moving, still arriving, still softly brushing against detectors built by hands that evolved billions of years later on a planet that didn't yet exist when the light began its journey. This background glow, though faint, is remarkably uniform. Look in any direction, and you'll find it, nearly the same temperature no matter where you point. But within that sameness are tiny fluctuations, minute differences in temperature and density, like ripples on a pond. These ripples are the seeds of everything. Galaxies, stars, planets all grew from the slight irregularities in that primordial light. Without those ripples, the universe would have remained smooth, silent, formless. It is because of their unevenness that the cosmos became interesting. Structure emerged from imperfection. Light gave birth to shape. We've mapped this background glow in exquisite detail. Satellites like COBE, WMAP, and Planck have captured it, pixel by pixel, turning the invisible into something visual, measurable, almost tactile. And from those maps, we've learned the age of the universe, its geometry, its composition. We've peered into the earliest moments, glimpsed the echoes of inflation, measured the balance between dark matter, dark energy, and everything else. All from a light that carries no image, no stars, no galaxies, only memory, only origin. It's humbling to realize that this faint, structureless radiation is the most pervasive light in existence. Not the glow of suns or the flicker of distant galaxies, but the faded warmth of a cosmos just beginning to exist. You are surrounded by it even now. It passes through you, through your home, through the earth. You can't feel it, but it's there, not harmful, just present, like the scent of something ancient, long extinguished, but still hanging in the air. This light is different from the starlight we've spoken of so far. It doesn't twinkle or shift. It doesn't carry the signature of fusion or motion. It is simpler, purer, and in its simplicity, it tells us something profound, that the universe has a history, and that history is written not in books or bones or myths, but in light. The oldest record is not carved in stone. It is etched into radiation. And because light travels, that record still arrives, still accumulates, like dust from a time before time. Even now, in the quiet moments before sleep, as your thoughts grow slow and the room falls silent, that ancient light continues to pass through you. It touches your skin, seeps into the walls, curls softly around the planet as it turns. It does not announce itself. It has no sparkle, no warmth, no urgency, but it is always there, steady and constant, a background hum beneath all other songs. And that may be the most intimate truth of all, that the first light still surrounds us, even after all these ages. That we live always in the residue of beginning, and that one day, long after our stars fade and our cities crumble and even memory is erased, that light will still be moving. It will stretch further, cool more, fade toward invisibility, but it will not disappear, because light, once freed, does not die. It lengthens, it slows, but it continues. And in that continuation, it becomes a kind of presence, a reminder, a persistence that says something was here, something happened, and that something left a trace. It's a comforting thought, especially in the stillness of night, that no matter how quiet things become, no matter how forgotten or distant or lost a moment may seem, light remembers. It doesn't preserve form or detail or emotion, but it carries the fact of existence, the proof of energy, the echo of fire. And as the stars themselves begin to age, as galaxies grow old, as stellar births slow, that ancient light will become more and more important. In the far future, when stars grow scarce and the night sky dims, the background glow may be the last visible light, the last flicker of origin, the last story still being told. So as you lie here, with your eyes closed, surrounded by the darkness of your own room, know that the universe is not truly dark. It is filled with light that has simply grown too quiet for your eyes to see, and that even in the silence, something ancient is still speaking. It doesn't need language. It doesn't need sound. It speaks through presence, through distance, through the soft insistence of photons that never stop traveling. And if this is what remains after everything else fades, then what, if anything, comes after even starlight has gone?